Welcome. In this session, we'll explore decision-making using unsupervised learning and clustering. This technique is very popular for businesses to understand natural groupings within a population of customers, for example, but it's used throughout all kinds of different disciplines to look at groups within a population and understand them better. For businesses, we want to be able to describe our customers as a set of attributes that define them, that help us understand them, and also for us to understand how we can craft products and services that are appropriate for them. And we want to build these groups that in a way that maximizes differences between them, but also that they're homogeneous, that they're similar within. And that's really the ideal situation so that we best know how to deliver those products and services where they are. Birds of a kind and a color flock and fly always together. 1554, this proverb, if you will, has taken off. Birds of a feather flock together. And this technique definitely shows that that's true. In an empirical way, we can measure that. So who are our customers? Most businesses have a population of people that they're trying to understand. And if I just look at that population of customers in this manner, I can't really distinguish one from the other. And I'm unable to maybe reach them with appropriate marketing messages or even better, appropriate products that really are going to address their needs and interests. So ideally, I would have a way of dividing up my population of customers into a segment, a group of customers that are more similar to each other, and maybe they have unique kinds of needs. Perhaps they have similar demographics or they have similar desires. And by knowing that, I can craft better products and services. And those are going to be distinct from the products and services that I deliver to a different set of customers. Yet again, a different set of customers would receive even a third. This was very, very important. Even if I'm going to be producing the same products and services, I know that the appropriate messaging or where the channels, for example, where these people are might differ. And these are the techniques that are really at that foundation for a business to make those decisions to effectively create what we know as a marketing mix so that we can identify appropriate channels and messages to go to all those kind of customers. This data has never been available more than it is today. And that's why you see these segmentation approaches becoming just so popular and prevalent. These are similar types of data that you would be able to receive from just about any kind of a website. These happen to be snapshots from Google Analytics that are available. And you can see typical kinds of things like age, gender, interest categories of customers that are clicking and visiting on the site are readily available and captured, locations around the globe of where visits have occurred. This has become so prevalent now that really we're switching away from to behavioral kinds of targeting or understanding our customers based on their actions or behaviors, because we're going to know so much. Obviously, we're going to know things about their purchase history and what they've purchased from us, their clickstream activities online, not only on our website, but actually other websites, such as where they've come from or what they do there. As partnerships in social media have blossomed, you will know different things about your customers' activity, often on other social media sites, if that's part of what you have purview to. And so you'll hear this idea that really businesses are trying to create personas or profiles of people by different lifestyle interests, because it's more important not necessarily just to know that someone has a high propensity to buy, but actually what they do, and knowing that they are into sports and other kinds of activities and their actual behaviors. That is a much more important for me to know, so that I can then have my ads or have my services tailored to exactly those kinds of activities. Now, one important note here, while I'm not going into great depth, this goes far beyond what's available just online in the kind of the web environment. Really, indeed, just about any physical environment, these kinds of data are available. And I invite you to visit a solution like IL Labs to see how common that is out in the real world for us to know this and indeed a lot more about different kinds of customers. So different types of approaches can be used for this. And the ideal segment, the ideal grouping, it needs to be stable enough for us to act on. And that's really going to be a business decision. We need to know that so that when we build those segments and then we want to take action on them, we can reach them via promotion and distribution channels. We can have the right message and we can have it in the right places at the right time. That's really the idea. The notion of homogeneity is important in this sense that we want to know enough that customers in that segment are similar enough so that I can have appropriate services and appropriate messages that are tailored specifically to them. If you have a lot of heterogeneity within a segment, it's not a very productive segment. It's not good enough for us to use in a reliable way. And on the other side of the coin, if you will, is we do want heterogeneity between our segments, and that's to say that we have a distinct enough set of segments to act on so that when we know with confidence that we're doing the right thing with our marketing spend for one segment, and that can be unique and different from the marketing spend or the product and services that I'm crafting for another segment. That would mean that they're different, and so that would be a very effective way of building our approach. And then finally, obviously, for us, from a business perspective, they should be profitable enough to act on. And all of these are caveats in a way because the models from a statistical perspective are relatively easy to build, and it's relatively easy and quick to get a lot of different customer segments. But if they're not usable and they're not profitable, then it may not be a direction that we want to go down. And a good business analyst is going to have indeed that in mind. It's a business decision that the analyst is helping with this solution. What do these look like? Well, these are really common examples that you can find out on the internet of how these different segments are built. So in this case, we have a family life stage segment, and you can see that we're ranging from things like leisure activities, frequency of going out, preferred destinations of where they go, common reasons to go out, average expenditure as they're going out, and then broken down into these different segments, and then perhaps the percentage of customers that are in our current business that represent those things to us. What any business that's building a segment is trying to understand is commonly these kinds of things: their propensity to buy, the propensity to grow, the propensity for them to switch to a different product, and the propensity for them to go with a competitor. And it's very common to see these kinds of metrics associated with different segments that would be built for us to then make the appropriate decisions. Looking at another example, very common, looking at labeling the different segments, so convenience seekers or brand buyers or casual buyers, again, all with a different kind of a profile of what defines that segment. And this data is going to be achieved through methods such as what I'm going to be sharing today that help us understand our customers and then effectively put them into appropriate buckets. So indeed, if this were our business, we would know that this is our most highly valued customers, or our top customers might be convenience seekers for this product or service. So indeed, this might justify a higher marketing spend and greater time and attention and resources to service relative to segments that are bargain hunters in this case. And it's very common to see these kinds of either depictions or some kind of illustration for these across the building of the segments. One last view, and indeed many of us today are hearing a lot about the millennial group of customers that are now becoming increasingly important to a lot of businesses, either because they're future employees or current employees, or they indeed represent a high amount of buying power. And so again, and this is another depiction from University of Southern California on how the millennial personas, which are effectively different segments, actually are represented in the population. So my next question would be, how does this fit with maybe the proportions that I have in my business? And in this class, we have looked at how we could use these kinds of percentages to evaluate whether our customers are similar to these kinds of metrics or not in the population, which then would tell me more about what I should do next on any of these things. Again, propensity to buy, grow, whether they're going to be staying with my product or staying with my company for very long. These can get very much into a level of evolution or maturity. So this is another depiction of using customer segments to understand that initial customer needs might be based on items that are not price sensitive. And then as customers become maybe more mature with the business, these segments might shift. And so something as important as price and why I see price sensitivity with certain customers and not others can often depend on their life cycle with us. New customers coming to us, and then mature customers become more, maybe in this model, more sensitive over time on price. So it's just another illustration of how businesses are using these kinds of techniques to understand their customers. Recently, an article was published to try to understand, and indeed I think these could be considered maybe part of the millennial generation that are shopping, but at least in a lot of the Western countries now, I would definitely consider America in this. There's a lot of subscription trials for virtually no cost, but companies are having a hard time maintaining those customers. I think this technique is used definitely globally, but this article is breaking down how many of those customers are canceling after three months of subscribing. 15% are coming only for a special offer, and so they've actually created new customer segments of what they call promotion abusers. New subscribers, active subscribers, and churn subscribers that are back for more a second time. So again, it's very common to see these kinds of breakdowns and how they play out with different businesses in the population and around the world. So how would we segment our market? If we had a product where we knew, such as something like t-shirts, that people have varying heights and weights, and maybe this is our entire population of customers, where would I start? How do I actually begin a customer segmentation process knowing that this is my product, t-shirts, and I know that I have different customers of height and weight? Well, a very simple segmentation might be beginning to group customers that have relatively small height and weight, moderate and high height and weight. And then this might lead us to have small, medium, and large t-shirts. But in this case, it could also tell us how small or how large, if you will, any of those sizes would be. Because it would also tell me that if my customers are of this size, I need to have a large that is at least within the limits of this sort of standard of height and weight. So segmentation is used not only for marketing purposes, but it can also be to help us build a better product, to know the capabilities that are needed for a different segment in the population. But indeed here, maybe I start saying that I have 3 customer segments. Looking at some additional data, here I have average distance driven and speed driven across let's say that it's across a month of time. And these are different people in the city. Each one of these represents effectively the average amount that's driven by an owner of a vehicle in that city in the month. And we can see here that we have some vehicles that have driven quite a bit, some not driving very much. And so intuitively, if I asked you, do you see any customer segments here? Groupings of customers that are more similar to each other and different than customers that are perhaps in a different segment or group, intuitively you might say, well, I see at least 2 different customers here. There's a group that is not driving very far, another group that is driving far. And so that might be the identification of a couple of different customer segments. Now, we can begin to ask, and I think it's very important as part of the technique, some additional deeper questions. Why do you believe that these customers are not driving very far? And some of them are driving faster than others. And I have other groups of vehicles that are driving far, and some of them are driving quite fast. Actually, you can see here, I would say if this were in miles per hour, maybe it's in kilometers an hour, but miles per hour, they're definitely speeding. Well, let's assume it's kilometers per hour. Nevertheless, they're definitely going much faster on average than these vehicles over here. And so it's that kind of thinking that really becomes sort of knowing your business and knowing your customers as to what's going on that helps us maybe say, actually, I see more than 2 segments here. I see actually maybe 4 segments here. I see a group of customers that are really not driving very much or very far, but some are driving further, but still not very far distance. And maybe I have a hypothesis about that. Similarly, over here, I have a group of customers that are driving far, but not very fast, and another group that are doing both. So, when I've talked with people about this data, a lot hypothesize that these might be commercial vehicles, for example. Maybe these are delivery vehicles that are within a city. They don't need to drive very fast, but they need to drive a lot in the day, for example. Maybe these are people that live very close to where they need to work, so they don't need to drive very far or fast. Vehicles that are up here, maybe these are commercial delivery vehicles that are long distance, that are going between cities, and so they're both driving at highway speeds and much further. The point is that knowing something about the type of business is going to be very important to do that kind of logical intuition around what we're seeing in the data, because the data itself doesn't tell you why the customers are grouping this way. Another feature to highlight here is the stars are representing what we call centroids. Those points are the point at which, within the group, they best describe the points that are closest to them, and they're distinct from the center point in these other groups. And I'm going to illustrate that further, but keep this picture in mind that these centroids are helping us to define the group, and it's effectively an average that best defines everybody that is in that group. And we've learned a lot about averages and central tendency in this course, and so you can see how important that kind of thinking is to this technique. Here's another example of segmentation on multi-attributes. So in the prior example, we were really just looking at effectively speed or distance, but it doesn't have to stop there. In this example, we have a group of countries that have been clustered on gross national income, life expectancy, and mortality of children under 5. And what you can see here is on these different attributes, the data are plotted in scatter plots looking 2 by 2. In this case, it's always going to be national income by either here mortality or here years expected. Or years expected of schooling in this particular one here, which isn't even the one on the bottom. So there's more than these attributes in the model. Nevertheless, you can see that there's 3 segments by color. And the idea is that we understand there's 3 clusters, but we still don't have any kind of label as to what these customers are. Now, this might be a good place to pause the video and just reflect on this data. Why do you think, and what does it mean that we have some countries in cluster 1 that have a relatively small gross national income, a sort of relatively short life expectancy, and a relatively high child mortality? How would you describe cluster 1? So hopefully you've come back with some kind of a analysis, because this is actually data, I believe, from the World Bank that describes these countries in terms of being developed, developing, or underdeveloped. And they've defined cluster 1 as these sort of underdeveloped countries that have relatively high mortality rates, relatively short life expectancy and such, and then more developed countries in cluster 3 have relatively higher earnings and a longer life expectancy and such. And so it's understanding something about the data that is really helpful in naming what's going on in the cluster. Again, the machine doesn't do that for us. How is the machine or the algorithms, a package like SPSS or any statistical package, doing this sort of calculation for us? It's using the k-means algorithm, and that relies on Euclidean distance. You might recall maybe in some earlier schooling about something with Euclidean distance, and that's exactly what is happening with these centroids. Let me conceptually show you how this is working in the model. Initially, when we start the process, we have data. Perhaps this is just simply one attribute, such as income for some kind of population of customers that we have. And I'm asking for 3 clusters. And so initially, the machine will start with what's called a seed point, which is a value that's selected in the data set to start the process. The k-means process. Using the Euclidean distance, it's going to pick pretty much at random, unless we specify otherwise in our technique, 3 values to start with. And that's what these 3 boxes in green, in orange, and in black represent. Now, once it does that, it's first going to calculate the distance between it and points that are near it or around it. So here I've actually illustrated that by darkening some areas that are near those points. And what's actually happening is it's calculating the distance between the cluster centers that it began. For example, this point here and this point here. And it's effectively marking the halfway distance between those 2 values, which could be a set of incomes, for example. And it's splitting the data right there. And we could agree that by doing that, all the points just on this line here, all of the points to this side have to be closer to this square, and all the points to this side have to be closest to this square. And that's how it initially begins. It continues the process doing the same thing here. Between this square and this square, it splits the difference halfway, and it basically then calculates that all of these values on this side must be closest to this point. All the values on this side must be closest to this point. And that process continues, and that's how it ends up calculating effectively the areas or the cases that are closest to the cluster centers, which is what these centroids are. Now, it doesn't stop there. Once it has these initial cluster centers, can we see a point where if these were to shift, I would be even closer to the values that are within its group? I think intuitively you can see that if this point was somehow moved over here, it would actually be closer to more of the values. This thinking probably sounds familiar in this class. We looked at this kind of thinking with ANOVA, for example, looking at mean squared errors being reduced. Same thing with regression. Being closest to the data points within some kind of a group was considered goodness, and that's what helps a model fit. And that's exactly what the machine does in these packages. It's going to now find the point at which it minimizes the distance between all the points within those groups. And it maximizes the difference now between these different points, because these are going to be more similar to this value, and these more similar to this value, and such. So conceptually, that's what's happening when we're asking for a cluster. It's trying to find the point that best describes the values within that group, however many segments we've asked. Here's another way of looking at this data. Banks are often very concerned about the profitability, which for them is going to be customers that might have a lot out on loans or on credit cards, and they are looking for those values to be very high, because if customers have a lot in loans or a lot on credit cards, they're going to be making more money on interest. But they're also very concerned about getting paid back, because a customer that has a lot of out on loan or on credit and then does not pay it back, they've lost money. So this is a very high risk situation if we have a lot of customers, if I'm a bank or a lending institution of some kind out here. So what they're trying to do is segment these customers into different groups. And indeed, these customers, they don't charge very much, they don't loan very much, and they pay it back, so relatively low risk. But as we're going out, these customers are charging a lot, and quite a few of them are not paying it off. So where would the customers that the bank most wants to have? Well, again, they're probably down in this range. This is a situation where these customers are paying a high balance, or carrying a high balance in loans, but then paying it off. That's great. Now, how do we maximize growing that segment? That could be a very legitimate question. And indeed, many banks have looked at this for growing different kinds of relationships with customers by understanding what it is that really motivates these kinds of customers to attain a balance, and then because they are a safe bet for the bank, relatively safe bet, the bank wins as well, because they're loaning appropriate high levels but also getting repaid. So that's the kind of general thinking. Now, in a banking situation, can be relatively straightforward because you know that you're in a risk business. But you can see this technique can be used for other kinds of analyses. So I ask you here to reflect on this. These are the 50 states in the United States, and they've been clustered into here 4 different clusters. Now, because we don't know anything about the underlying data, it becomes very difficult for us to make sense as to perhaps why different states have been clustered together. So whether or not you know a whole lot about the United States, I can share with you that not all of these are necessarily located in any kind of region that are next to each other. Here we have the state of Maryland and we have the state of New Mexico. This state is located in the far eastern United States. This is a far western state, and there's other western states that are here. Why is Maryland, clustered here? Florida, again, being associated with this cluster. So you have to know something about the underlying data. The machine is simply not going to do that. It's just going to find something similar based on the attributes that you're feeding it, the variables that you're feeding it in the analysis, and try to find a similarity. So without knowing more, it's anybody's guess as to why these particular groupings have resulted. And that's part of the challenge with using a clustering technique. That's why it's called sort of unsupervised learning, is we're going in with no intuitive design. It makes it very difficult for us to then make sense of the data. Another challenge about this technique is just how many clusters do you really have? So in this situation, this is the same data in every one of these charts. The only difference between the data are, do we see 3 clusters, 4 clusters, 5 clusters, or here 6 clusters? And you can see the machine will have no problem continuing to give you pretty much as many clusters as you ask. And it will find groupings that are relatively similar within the data for those different attributes or variables. The challenge is really going to be one that the business has to face. And I've always counseled folks that are trying to do these analysis is, if I don't have a marketing or a go-to-market strategy that's any bigger than 3 customer segments, it may not make sense for us to design 6. However, a lot of data scientists and modelers will be very pleased with a model that has more attributes in it, more clusters. In this case, 6 clusters, because this version of the analysis will fit the data better. And that's going to be very much the case almost every time. But if the business can't operate on any more than 3 clusters, 3 customer segments, low value customers to high value customers and some in the middle, it may not be worth it to design a campaign or design products that are this diverse. Or if you're in this situation, maybe that's an opportunity to mature into. This could show you that if this fits the data better, what do you need to do to mature your organization or mature your products and services so that now you have 6 offerings? So it could be looked at as an opportunity to mature and grow. But if you cannot operate on any more than 3, I wouldn't recommend trying to do that, because it's probably going to be a frustrating at best and maybe actually costly to you and the business and your customers at worst. Here's another challenge with this effort. It's sort of related to the 6 cluster design we just looked at. This is a model of what we call overspecified. So this is a case where every shade that you see slightly different in every grouping that you're seeing, those could be considered different clusters. So how many clusters do I see? I see 3 big clusters, but then I also see these little minute clusters within. And again, if I don't have a strategy to understand why I'm treating this particular set of customers differently than these customers, then this could be an example where we've overspecified the model. Overspecified meaning we've just asked for too many segments. And that's a business decision to perhaps go back and just look for 3 big clusters that you and then the business can understand, because that's probably going to be more effective. Now, there are other kinds of packages that allow clustering to be done today, and I'm illustrating one here, Tableau. I'll do this also live in just a moment. And I think this is another reason why these techniques have become so popular. It's because in the past you needed really sophisticated tools like SPSS to actually build a cluster for you. But now it's become practically just drag and drop. So here's a situation where I have some country data. If I want to have an analysis looking at annual wages across countries, that's how I can produce a chart that looks like this. And then the cluster analysis is even easier than in SPSS. It's just a click away. I can just let the machine give me a set of clusters. In this case, it's created 4 clusters. I'm going to sort this just so that we can see it a little bit better. In this case, looking at annual wages, I now have 4 clusters, which is what the machine thought was best representing the data, meaning that these countries have a value, a centroid that best describes them, that's distinct from the countries in that grouping and this grouping and this grouping. But again, you can pause and maybe start to reflect on, why do you think Denmark, Sweden, and Norway and Luxembourg have clustered together in the cluster 4 versus cluster 3 and such? And you can see it might be rather challenging to do so. It's also very easy to explore and perhaps ask for different clusters. So if I think that that's just too many, I could go back and just say, well, I really want just 3 clusters. Tools like these, though, have become very effective because I can also ask for the clusters to be represented in space. This is right now it's a little difficult to get anything like this on SPSS at a click, but you can see in Tableau these visualization tools for big data make this very easy. And this also can help with hypothesis building as to what I'm actually seeing in the cluster, and maybe then have a theory as to why these countries are all similar to each other, and these countries are somehow different, in cluster 3. You have very distinct countries all coming together, so you have to have some kind of a theory. Now, you can actually measure these clusters in the tool, and I'm going to illustrate that. I was just looking at the attribute of wages earned, but you can see you can add additional components that you have in your data. In this case, all the data is represented here. It's very easy to drag these over and then ask for new clusters. Once you have the cluster into the tool, you're able to get a description of what was in the model. So in this case, we have 4 clusters. It's showing us the actual data that is in the cluster and what their values are, so that we can interpret them. And it's going to give us some general statistics. So here are F statistics showing the significance. So here are p-values, which I know you know how to interpret now on those different elements. And I can see here that adding the element of spending on healthcare is non-significant because the p-value is greater than 0.05. And by standard, I would have expected to use a 0.05 level. And perhaps this is telling me this is not really helping me in the model. It's becoming maybe overspecified, and I might want to drop it out and then look at the clusters without it. So I'm sharing that with you just to illustrate that these kinds of techniques are easier than ever before. These tools are readily available, and that's why you're seeing so much talk about segmenting customers like this. Here are the slides I just shared with you just in a static view. So I'll just skipping ahead here. This is the full model that you're able to get. And we'll be looking at this a little bit later. One of the ways that you can know that you're starting to get a model that's overspecified, it could be that it's not really adding any more value to ask for more clusters. And so you can get a chart that will show you the average within cluster distance to the centroid. In other words, how well 2 clusters are at defining every single point in the data set, or 3 clusters, or 4 clusters. After some point, adding another cluster is not really helping me understand the cluster any better. And the points are just so close to the cluster center that I must be defining a very, very, very small segment of the customers. And so perhaps this is sufficient for me to have just a 4 cluster solution. And there are different ways of getting that. I've provided some resources below. This is great advice from George Box. The idea is that all models are, all models are imperfect in some way, but some are useful. And we're really looking for something that's good enough. You're not going to get something that's absolutely perfect when you're trying to do these techniques, and so you're looking for good enough, and the chart that I just shared with you is one way to do that. Some considerations when we do these, you really need to understand what attributes or what variables you're going to include in the analysis. Also, these techniques can be sensitive to the unit of measure, so I'll be showing you some of that to you. It's important that the technique, such as Tableau's technique, standardizes the data by default so that you're getting an unbiased estimate of what's in the samples, but that's something you have to watch for. SPSS won't do that on its own. You'll have to tell it to do that if you choose to do that technique in SPSS. You need to understand about that rescaling, and so that you don't get disproportionate effects in the results, because you will get clusters in this example of miles to kilometers, and that could require rescaling for you to get a better actual fit. Are the clusters well separated from each other? We just demonstrated that looking at the world data for salaries and adding in some other attributes. And you can see if they're so close together, it can be very difficult sometimes to interpret the results. And you also want to look for the clusters having only a few points. Both the SPSS and the Tableau output, for example, will show you the number of cases that are in the points. I think one of the clusters we just looked at only had 4 cases in it. So 4 is very, very small when you're looking at world data. That might tell you that you've overspecified the model. So the takeaway that we've looked at today is clustering is a really effective method for discovering patterns and describing groups in data. This method is really effective when you have a theory or a hypothesis that's helping you interpret the data about knowing your customers or knowing your products and services. I wouldn't allow a naive analyst to just build clusters and give them back without any hypothesis that's driving the technique, because it will become unwieldy to interpret. Clustering and segmentation really help us as companies make sense of our customers and our markets, and that really helps us make decisions for promotions, products, and services.